Graphing yesterday, was it terribly difficult? No. Except for those fraction ones kind of sucked, didn't they? Okay. The ones where you had like a y-intercept of a fraction, then it was tough. Otherwise, you're like, whatever. Okay? Some people did. Okay, so what happens? What happens if I wouldn't give you graph paper? I wouldn't give you Alex. You want to graph them? I wouldn't choose to. It's not hard, but it's not going to be my top pick. Okay? So graphing, yes, can always get an answer, but I think it's time consuming and it's not always easy to get that perfect answer. Alex is really good because it does line it up for us perfectly. So another option we have to solve systems of equation is substitution. We've talked about substitution before. When two things are equal, you can swap them out. Find the value of y in the equation y equals 3x when x equals 5. We can use substitution. Because we know x equals 5, we can replace x with 5. We can substitute in 5. Y equals 3 times 5, so y equals 15. That is substitution. You've done this before, okay? Just not to the same degree, but you've used substitution. It's like in football or basketball or volleyball. You want to trade out players that can play the same position. Or in band, you probably don't want to take somebody that plays percussion and ask them to play the trumpet. Like, that's not going to go well for anyone. Okay? Or the train whistle. I mean, that train whistle sometimes is necessary in there. So today, our substitution, remember, is involving systems of equations. So we're going to have multiple variables. When you have a variable alone, y or x, you can plug it into the other equation. Now, you really don't want to deal with fractions, agreed? So I would avoid them at all costs. So, use substitution to solve the systems of equations. One of my equations is y equals 2x plus 1. The other one is 3x plus y equals negative 9. First thing we have to do is we have to look at those equations and say, do I have an equation that a letter is already by itself? On the left, agreed? Y is by itself. So I can use substitution. I can take 2x plus 1 and replace y in the other equation. So 3x is going to stay plus 2x plus 1 equals negative 9. Okay, so I swapped y out. Why is that a benefit for me to swap y out? Caden?
So then you have an easier problem to work with.
What makes it easier?
That you have no y variable.
There's no y variable. You're down to one variable. You guys can go back to chapter 2 and solve this, right? What's my first step to solve for x? 3x and 2x gives me 5x plus 1 equals negative 9 minus 1. 5x equals negative 10. Divide by 5. X equals negative 2. Are you done? Yesterday, all of your answers were ordered pairs, right? Today, still the same thing. You're going to have an ordered pair. So now that I know x is negative 2, how do I find y? Plug it in. Okay? Do you want to plug it into y equals 2x plus 1 or 3x plus y equals negative 9? I would pick this one. How come? Y is already by itself, yes? So replace your x, so it should be y equals 2 times negative 2 plus 1. Hey, be careful. Did you put negative 2 in parentheses? Otherwise, it looks like 2 minus 2, right? Okay, what do I do first? 2 times negative 2 is negative 4 plus 1, negative 3. Now, in Alex, it's going to have a separate blank. Tell me what x is. Tell me what y is. Sometimes they ask you for an ordered pair. What would this be written as an ordered pair for your answer? Negative 2, negative 3. Secret. You want a secret? You can check every single one of these problems to make sure you don't get them wrong. Do I think you're going to do that on your homework? Probably not, because you have a check key, right? Do I think it's an easy way for you to check your homework on a test? What do I have to do? Plug it back in. If I plug 2 for x into this equation, y should give me negative 3. If I plug 2 for x, y should equal negative 3. Negative 2, sorry, negative 2. Okay, so we know it does here because we just did that. But if we checked over here, replace x with negative 2. 3 times negative 2 plus y equals negative 9. What's 3 times negative 2? Negative 6 plus y equals negative 9. Then you should add 6, y equals negative 3, which is what we wanted, right? It plugs into both to give us the same. If you plug it in and it doesn't end up the same, you made a mistake someplace. Okay? Let's go to the next one. What's different about this one? Yeah, what is that called when it's got that number in front of it? It's got a coefficient other than 1, right? So same process, y is by itself, so we're going to take 4x minus 6, and it's going for y. But what am I going to have to do here? Yeah, I'm going to put it in parentheses. So I have 5x plus 3 parenthesis 4x minus 6, close your parenthesis, equals negative 1. Now what do I need to do first? Distribute. What am I distributing?
3
Positive 3. So what do I end up with? 5x
plus 12x
plus 12x
minus 18.
minus 18 equals negative 1. Then 5 and 12 gives me 17x minus 18 equals negative 1. Add 18. 17x equals 17. Divide by 17, x equals 1. What do I do with that? Plug it back in. I'm going to plug it into the left. Is that okay? Y equals 4 times 1 minus 6. 4 times 1 is 4, minus 6 is negative 2. So if you were going to write this as an ordered pair, you would write 1, negative 2. 1, negative 2. Okay? How about the next one? Not quite as pretty, agreed? What's different about this one? We don't have one letter already by itself, agreed? Remember back at the beginning, I just said avoid fractions at all costs. Does one of those equations, either the left or the right, make more sense to get one of the letters by itself? Which one, the left or the right? Which letter should we get alone? Fight it out. Who's right? Who's wrong? Why should I get x by itself, Thatcher?
Because then you have to divide.
Why don't I have to divide?
Because there's no coefficient.
Ooh, there is a coefficient, but what is it?
1.
A 1. If you get x by itself, what would you have to do to get x by itself on that left equation? Subtract 2y, right? So you'd have x equals 6 minus 2y. No fractions, yes? What if I was going to get y by itself? I'd have to subtract x, and then I would have to divide it by 2. Why is dividing it by 2 troublesome? I'm going to have a fraction here. Do we want to deal with fractions? Okay, so let's think to ourselves, what general rule of thumb can we make when I'm trying to pick which equation and which letter to get by itself? What am I looking for? A 1 coefficient. That way I don't have to divide. Very good. So I'm going to go back with what Thatcher said, okay? So in this case, we had to make a first early step and get x by itself, and we chose x because that is a 1 coefficient. So now the rules don't change because x is by itself, other than you're going to replace what? X this time. So this is going in for x. So I have 3 parenthesis 6 minus 2y. Close your parenthesis, minus 4y equals 28. Solve for y, see what you get. What'd you get? -1? I got -1, so double check me. Then what are you going to do with that -1? Plug it back in. Does it matter what you plug it into?
Or
Technically, you could plug it into any of them. And somebody always is going to say, can I plug it into this one? As long as you have confidence that you didn't screw up your signs on that, yes. I always go back to one of the main ones. So I'd go x plus 2 times -1 equals 6. X minus 2 equals 6. X equals 8. Is that what you guys got? So 8 comma -1. You know what's silly? One of the most common mistakes that people make on ALEKS, they put the wrong numbers in for the wrong letter. Like everything on their paper is correct, and they put the wrong number in the boxes. So pay attention closely to that, okay? Try the next one on your own. Start to finish. Gonna make it back there? Yeah. I just heard a grumbling of, oh man. Why are you all manning? Oh. Why is he all manning? How do you know it's infinite solution? What happens here? Help me out. Okay, so these guys right here cancel, right? -6x and a +6x. So you have -12 equals -12, which means infinite solutions. Because they're the same number with the same sign, it means infinite solutions. Meaning, if I was going to graph those, what's going to happen? They're going to graph right on top of one another, yes? Okay, they're going to graph right on top of one another. Tell me what I need to be cautious of on this guy. The bottom one there. Say, okay, so I'm going to use this one, and I'm going to plug it in for y, right? It's a -y, so what is that really? A -1. So many people forget they really should write that as -1 parenthesis 2x minus 3, because that negative is going to have to be shared on the inside. It's like distributing there. Well, you're replacing y. Really, this is like -1y, right? And then you replace y. So you end up with 2x minus 2x plus 3 equals 8. What happens? Yeah, 2x and -2x cancel. 3 equals 8 is no solution. If you graph those, what's going to happen? They're parallel lines. And I know it's no solution because 3 and 8 are not the same numbers. Okay, not the same numbers. Let's just talk. I won't make us do this whole thing start to finish, but let's just talk what's the first thing I should do on this problem. Why Alexa? Why? Very good. This y has a 1 coefficient, so I want to get that y by itself. What would I do to get that y by itself? Add 3x, so you'd end up with y equals, you could go 3x minus 13, or you could go -13 plus 3x, right? And then plug it in. Do you want to work through that one, or are you good? Okay, I figured so, but I don't ever want to assume. Let's do one more together. Your favorites, right? A store sold a total of 125 car stereo systems and speakers in 1 week. The stereo system sold for $104.95, and the speakers sold for $18.95. The sales from these two items totaled $6,926.75. How many of each item were sold? That very last, that'll take you forever. That very last sentence is going to tell you about your variable, or I'm going to hint at variables. How many of each item were sold? How many items are we talking about here? 2. We're talking about stereo systems and speakers, right? What variables do you want to use? I love that you guys choose X and Y. X is going to stand for what? You pick. Number of stereos. Number of stereos. Y is going to stand for the number of speakers. Here's what I'm going to tell you. Because you're solving a system of equations and you have two things that you don't know, you're going to write two separate equations. And in those equations, they're both going to involve X and Y, and you have a slim to none chance that you're going to double up on the numbers. Like if you use the number 125 in the first equation, you're not going to use it in the second equation. So can anybody take those sentences and tell me one equation based off of the information given? Thatcher.
X plus Y equals 6,926.75.
Thoughts? Agree or disagree? The number of stereos sold plus the number of speakers sold equals $6,926.75. Disagree. Miles?
The answer should be 125.
Oh, you're telling me it equals 125?
Yeah.
You want me to erase this?
Yeah.
So you're telling me the number of stereos plus the number of speakers is 125? Okay, so that in that case, you're absolutely right. A total of 125. So the two items, just if you counted, 1, 2, how many boxes went out? You have 125. Be cautious with your money. You got to have money show up, right? Fix your equation, Thatcher.
So, X or 104.95 X plus 18.95 Y equals 6,926.75.
Thoughts now? Did he fix it? Involves that money, right? $104.95 times every stereo is going to give you the total amount sold for stereos, plus $18.95 times every speaker, and then those two added together gave me a total sales of $6,926.75. Yes. Now let's definitely pick the bottom one and get X by itself. Agreed? Okay. Clearly pick the top one, yes? You want to get X or Y by itself? Y? Okay, so X plus Y equals 125. How do I get Y by itself? Subtract X to both sides. So Y equals 125 minus, I'm going to put a 1 in front of that X just so I don't forget it. Now what do you want me to do? Okay, so 125 minus X is going to go into your other equation for Y. Be careful with your decimals. 104.95x plus 18.95 times 125 minus 1x equals $6,926.75. You guys solve for X. See what you get. What'd you get? Are you not there yet? Oh, sorry. What'd you get for X? 53. Question. If you would have gotten a decimal, should you have rolled with it? What does X stand for? How many? A number of items, right? Like I sold 52.7 stereo systems. It doesn't really make sense, agreed? Now, if it meant money, that would be acceptable then to have a decimal. But in this case, it's gonna. If you don't end up with a whole number, you should panic. Okay, so what do I do with that 53? Plug it back in. So 53 plus y equals 125. What'd you get for y? 72. Now, on a problem like this, you got to label your final answer. So go back and they ask you, how many of each item were sold? You would say 72 speakers and 53 stereos were sold. Now, Miss Hoff's handwriting sucks in this problem. I almost couldn't read my own. And some of you fall into that same trap at times because you get going so fast. Okay, help yourself out and be cautious of your handwriting. I don't know about you, like graphing's fine, but I like problems like this where I can plug through a lot better. I'm a nerd, whatever you want to say. Okay, get your scratch paper from back there. 6-2 online, do it 8 a.m. Yes.